Guys, hope all of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In this particular discussion, I'm going to look at the concept of moments of inertia, and kindly request our members to subscribe, engage ourselves in the comment section, and also ring that notification bell to be getting updates on our various discussion in math and sciences. Now, in this particular case, I'll also like to request our members to be checking out description boxes. I'm going to put a link of similar discussions, basically which are going to be contained in terms of a playlist. Kindly open and check for other similar discussions which we are going to do under the same topic. Now, in our discussion today, I'm going to look at the concept of moments of inertia. And this is going to be assisting us in trying to tackle other areas which we are going to come across, particularly in mathematics and sciences, whereby we're going to deal with different subjects. Now, the concept of the moment of inertia is going to be relevant for us, especially in trying to describe how particularly devices can hold to external forces. And this is going to be one of the application areas of this specific concept of the moment of the inertia. So in this case, we are going to look at some of the application in areas of devices which basically work in a sense that are going to utilize the aspect of motion. Now, therefore, for us to understand how these devices are going to cope with the external and the internal forces, then therefore we're going to learn this specific aspect from the concept of moments of inertia. And then secondly, we're going to see that the concept of moments of inertia is going to be very crucial, especially in determining the concept of angular momentum. So in this case, in order for us to evaluate or calculate the concept of angular momentum, we're going to use the concept of moment of inertia. So in this particular case, then therefore, so this is going to be momentum. Now, in this particular case, then therefore, we're also going to see that this is basically momentum. So we are also going to see that for us to look at this specific concept, this is going to be handy in assisting us analyze and predict the concept of rotational motion of objects. Now, in this case, these are going to be, so this is going to be rotational motion of objects. These are going to be some of the areas which we are going to come across whereby there is application of the moment of inertia. And in our statistics, of course, we have come across this specific aspect of moments in one way or another. So kindly check our description boxes for various links of other similar videos which are going to assist us in trying to appreciate this broader topic. Now, in a sense, the concept of the term moment of inertia, this is particularly a topic which is derived from a combination of these particular words which I've used. Now, the concept of a moment basically is going to be defined from different aspects, or in its context, in this case, in the subject of physics, whereby we're going to see that it's a property that's going to assist us in trying to determine how perhaps or describe the rotational effect of a force about a fixed position. And in a sense, we can as well determine it, define it as a turning effect of a force around a fixed point. Now, in this case, as we can see from the two statements which I've mentioned, I've talked about the concept of a force, and I've talked about the concept of a fixed point. And therefore, this aspect of a turning which I've just described. So in our description of the concept of this aspect of moments of inertia, we're going to concentrate on these three specific aspects, whereby there's going to be a force applied, and then there's going to be this particular fixed point, whereby we're going to concentrate on distance and the direction of that specific aspect of a force. Now, therefore, the moments of inertia is going to be a combination of this specific term entailing the aspect of moment, and there's this term which I've particularly mentioned about the concept of inertia. And this is a derivation from the Latin word inertia, which means sluggish or idle. So in this case, we are going to look at this specific aspect of inertia, which is basically derived from the Greek, or rather the Latin word inertia. And this specific word literally can be given a symbol of being idle or reluctancy to change. So therefore, we can define this specific aspect of the moment of inertia, whereby we're going to see that we can use a particular aspect of a body which is going to be experiencing particular force. And therefore, we can define the concept of moment of inertia of that specific body, having defined, of course, what moment is and the concept of inertia. So therefore, the reluctance of a body to change the state of its motion can be referred to as the moment of inertia. And this is going to be the property of a body which makes it reluctant either to slow down or speed up. So reluctant to either slow down or speed up. Now, in a sense, we're going to see that this specific aspect is going to try and, of course, maintain a particular body which is either in motion or a particular state to maintain its particular or initial state. And this is going to be defined as the moment of inertia. Now, this is going to be a property of a mass and can be defined as a second moment of mass, whereby we're going to see that apart from the concept of moment, whereby I talked about the force fixed position and that specific aspect of perhaps rotation, we're going to see that the concept of moment of inertia is a property of mass, which as well is going to be given as a second moment of mass. Perhaps this is going to be more elaborate for us when we're going to define it in a specific perhaps algebraic representation. But we're going to see that this reluctance of an object is not only going to depend on the mass of the rotating object as well. And I mentioned the concept of a position, and therefore or from a fixed point, and therefore we're going to consider this specific fixed point which is going to be, in addition to mass, is going to influence this specific aspect of the moment of inertia. So I've given these two specific illustrations on my right side of the board in order to illustrate this particular aspect of a mass, or rather the moment of inertia, whereby we're going to consider the turning effect of these two specific, of course, setups. So I'm going to perhaps have this so that I can use that one to show or to illustrate this aspect of moment of inertia for the two objects. So here we're going to have a cylinder of radius r1 given as such. So there's an axle which is going to run through the middle of this specific cylinder from this specific point to the other end. And of course, we're going to have a disc, cylindrical disc, which is going to be given as such, and an axle running through its middle center. So in this case, if we are going to try and turn this specific cylinder and the disc respectively, we're going to witness some amount of amount of force which is going to vary if at all we consider that this specific cylinder is going to consist of a mass m, and therefore which is going to consist of the same mass regarded as m. So if this one is perhaps 20 kilograms, this is also 20 kilograms, and therefore we're going to see that they're going to be objects of the same mass. But upon turning them by applying some kind of a force, we're going to see that the first one is going to be easier to rotate. So this is going to be easier to rotate compared to the lower one, which is basically going to be harder to rotate. And therefore, this is going to be defined, or the difference between the easiness or the hardness to rotate those two specific objects of equal mass is going to be due to the concept of the moment of inertia. And this is going to be the resultant of this, or the result of this one is going to be due to the, of course, the distance from the what we are going to refer to as this specific origin for the diameter, so as we can refer to as the center. And of course, that's going to affect these two specific objects. Now, we're going to see that for the first one, with all the mass near the axis of this particular illustration we have given for the axle, it's going to be easier for us to rotate it as compared to the second one, whereby the object is made up of equal mass, but the mass is spread over a larger diameter, as we're going to see in this case. So this is going to be having an effect on how easier or harder we can be able to rotate those two specific objects, and therefore this is going to be due to the moments of inertia of those two particular objects. Now, in our next discussion, we're going to look at how we can derive this aspect of moment of inertia, in considering some of the aspects which we have talked about concerning mass, the distance from that specific center of rotation, etc. Now, in this case, we're going to consider the mass of an object, whereby I can just give this specific illustration given as such. Let's consider that this is a mass which is going to be rotating, shown as the one above. So we can consider the distance from this specific point to this one given as r, and therefore this is going to be the position about which this specific object is going to rotate. So we can perhaps indicate the direction. So let's have just this one as r, which is the distance between this specific point and the mass, and then therefore we're going to have this one being rotated in that specific direction. Now we're going to consider in this case the perhaps from circular motion, we're going to consider velocity as given as angular, and therefore we are going to see that we can describe the first moment of mass of this specific kind of rotation by finding it as a product of mass times the perpendicular distance. So this one, of course, is going to be given using the previous concept which we have defined for a moment and the concept of a mass. So the first moment of mass can be described as the product of the mass of this object times the perpendicular distance, which we can give perhaps perpendicular distance. So in this case, we're going to refer to this distance as the distance from the original point, or this center point, to the mass, which is given in terms of r, and therefore this is going to give us a relationship of the first moment given in terms of mass times r, given as such. And from this one as well, we can define the second moment given as, or the second moment of mass given as the product of mass times twice this specific, or not twice, basically the square of this specific distance. And this can be defined in terms of this specific initial. So we're going to use this particular initial in representing this particular aspect of the moment, and therefore we can have this one given in terms of perhaps I give it as mr squared. So this is going to be the second moment of this specific mass which is undergoing this aspect of a rotation. So therefore we can find the total mass of the total moments of rotation of this a system of which is analogous to this by the summation of all the elements of this mass and the square of the distance between them given as such. And of course that's going to be giving us this specific representation for the moment of inertia is equivalent to the total mass given as such and the square of the distance between them, which is basically going to be the second mass. So therefore, in terms of algebraic or a representation, in terms of an equation, we're going to have this one representing the moment of inertia, and which is going to be the second mass, the second moment of mass represented as the product of these two specific aspects for the mass and the distance. So we're going to see that in ideal situation, remember we have described these two scenarios for A and B, considering them to be cylindrical and therefore having a circular kind of a cross section. But in our normal cases, we're going to come across bodies which basically are going to have perhaps this specific center of concentration of mass is going to be not as defined as such. And therefore, there's a way in which we're going to consider in trying to find the moment of inertia for such a kind of bodies in our subsequent discussion. So kindly, as I have said, check our description boxes for various links of other videos, and also ring that notification bell and subscribe to our channel to be getting various updates on different subjects we do in mathematics and sciences. So that is it for now, guys. Bye, God bless you. Catch us in our next video.